Uh, okay. Today, inshallah, we have a new subject. I think we already finished last time. So, I think we finished mathematical induction until last example. Okay. So today we have a new subject, which is counting methods. Okay, so our subject today, counting methods. Okay, so in counting methods, we have many subjects related to the counting. First, we will take the basic counting rules, which is 3 rules: product rule, sum or summation rule, subtraction rule. 3 symbols rule to make counting, and then we will take something called Pigeonhole Principle, and it's one of the important counting methods also. And finally, we will take the permutation and combination. I think permutation and combination, you already took it in the school, the secondary school. So it must be easy for you. Actually, today's subject, it's easy subject, but need focusing from you to know which counting method or counting rule you have to use in specific situations. So this is the idea. The idea, you must know which counting rule or method you have to use. If you know which one, you will find that the question very easy and you can solve any question easy. But the most important to select the appropriate rule or method for this problem. So your focus must be about understanding the problem itself when you have problem question in the exam or exercise in the book or so on. The most important is to understand what's required from this question to know which rule you have to apply. Okay, so let's start with the basic counting rules. Product rule, summation rule, and subtraction rule. Simply, a product rule, when you have a sequence of tasks, okay? So, for example, if you have a procedure means something you want to do, okay? Select people from the class, write some letters, give numbers for the chairs in a hall, and so on. You have procedures, something you want to do, and this procedure can be broken into a sequence of 2 tasks or more, maybe 3 tasks, 4 tasks or more. So, for example, if this procedure can divide it into 2 tasks, and each task, for example, first task have n number of ways to do this task, and second task have n 2 ways to do this task, then there are n1 multiplied by n2 ways to do the procedure, the whole procedure. So you have procedure, you have problem, okay, and this problem divided into 2 tasks. You have n1 way to do this task, number of ways, 10, 20, 100, okay, and n2 ways to do this task. So to do the whole procedure, you have n1 multiplied by n2 ways to do this procedure. We will return for product rule with example. Okay, what about summation rule? Summation rule, if a task, one task here, we don't divide this task, we speak about one task that can be done either in or using n1 ways or in 2 ways. So to do one task, you have 2 different group of ways, n1 ways or in 2 ways to do this task, where n1 this ways and n2 this ways are different ways. Okay, there is no intersection between n1 ways and n2 ways. If there is intersection, then there are n1 plus n2 ways to do the task. Example, if I said we need to choose one from computer engineering, one person. We have teachers and we have students in computer engineering. If the teacher cannot be student and the student cannot be teacher, in this case, we have in one way to choose from teachers and in 2 ways to choose from students. So to choose person from the teachers or the students, we have n1 plus n2 ways to do this task. What's the task? Choose one person from computer engineering, from students or from teachers. So summation rule here, we have 2 groups of ways and there is no intersection between these ways. Okay, for example here, teacher cannot be student, student cannot be teacher. If there is intersection, then we can apply the subtraction rule. So subtraction rule, actually, it's very similar to the summation rule. The difference here, when we have shared way between n1 and n2, or common way between n1 and n2. So if a task can be done either using n1 ways or in 2 ways, until here, it's same like summation. But what's the difference? The difference, if we have a number of ways shared common between n1 and n2, then the number of ways to do the task is n1 plus n2 minus, here's the difference, minus the intersection, minus the number of ways to do the tasks that are common. Okay. if we said that we have in the engineering, computer engineering, we have, for example, 15 teachers, okay, to make it simple only, and 80 student, okay, 80 students, and we have 5 who is teacher, or 5 of the teacher here, and the student. At the same time. So we have 5 from this 15, 5 teachers and the students at the same time. And from this 18, we have 5 students who is teachers at the same time. Then how to solve this? Here summation, it's not the correct answer. The correct answer is subtraction rule. So the rule will be like this: N1 plus N2 minus N1 intersect N2. We will take it by examples and in detail all, okay? I just make like overview here. So N1 means we need to select one from the computer engineers. This is the example here. And sorry, you have any question? Okay, just let me do something here. Okay. So to select one from computer engineer, and we have 15 teachers and 80 students, and between these 15 teachers and 80 students, we have 5 shared as teachers and the student. So to select from the teachers, we have 15 ways because we have 15 teachers. And to select from the students, we have 80 ways. And this minus the intersection, who is 5, it's common between the students and the teacher. So the result is 90 ways to do this job. So this is the idea of subtraction. When we have between these two groups of way to solve or to do the task, when we have intersection, we have common ways, then we minus the intersection. Summation, when the two groups of way to do the solution, there is no intersection between them. And a product, when we need to do a procedure, and this procedure have two sub-task. So we need to do this task and we need to do this task to establish or to do the procedure. In this case, we multiply the number of ways to execute the first task or to do the first task with a number of ways to do the second task. If we have 3 tasks, subtask, then number of ways of the doing the first task multiplied by doing the second task multiplied by doing the third, the fourth, the fifth, and so on. We will take each one with examples, inshallah, now. Okay, so product rule. Look to this example. This example says the chairs in an auditorium, like the cinema or like any hall for doing events, auditorium, are labeled by uppercase English letter. So we have auditorium like this. We have chairs here. And chairs, okay, and here you have usually the screen or the place for doing the events. And what do you need? You need to label this chairs. To label this chairs, each label contain like this, contain uppercase English letter. So we have uppercase English letter, followed by an integer between 0 and 99. So first we have letter, for example, A, uppercase only. Then we have number between 0 and 99. So we have number like 00 or 01, 02 until 99. So we have 2 tasks to do this procedure, to label this procedure, label the chairs. We have 2 tasks. First task, select the letter A or B or C. Second task, select the number. How many ways to select the letter? How many options we have for the uppercase English letters? We have 26 letters in the English language. So we have 26 ways to pick uppercase letter. And how many ways to pick integer between 0 and 99? We have 100 ways. We have 0, 0, 0, 1, 0, 2, 0, 3, 0. This is the options that we have until 99. It's 100 ways. So to do the whole procedure, which is label the chairs, okay, we have 26 way, which is N1, yes, to choose the letter, multiply by 100 way to choose the integer. So the result is 2,600 ways to label the chairs. Okay, we can ask the same question in different way. For example, what's the maximum number of chairs we could have in this hall with different labels? If the labels contain uppercase letter in English, 1 uppercase letter in English, followed by an integer between 0 and 99. Same question, same answer. So to get the maximum number of of chairs here with different labels, we need to know how many ways, how many labels we could have. So what is the largest number of chairs? This the question can be labeled here. The other question, how many how many different label we could have for this chairs, and so on. So this is a product rule. Let's take another example. Okay, so if we have only 2 tasks, it's easy. If we have more than 2 tasks, we can simply generalize the rule as if we have k task, so n1 multiplied by n2 multiplied by n3 until multiplied by nk. This is a general way. Or it's actually n to power k. We will see it now. For example, how many different bit string? Bit means 0 or 1. How many different bit strings of length 6? So we have how many digits here? We have 6. 1, 2, 3, 4, 5, 6. Each one is a bit. So could be 0, could be 1. Could be 1, could be 0, and so on. So how many different bit string? First string could be 0, 0, 0, 0. Second one 0, 0, 0, 0, 1, and so on. How many different bit string we could have? To do it, it's actually, we have 6 tasks here to do this procedure. First task, to get the first bit or first digit. It could be 0 or 1. So how many ways? 2. Second task, to get how many ways to get the second digit. How many ways we have? Also 2, because we have 0 or 1. So how many ways to select between 0 and 1? 2. Same idea. Also, I need 2 ways here, 2 ways here, and so on. So to do the whole procedure, we multiply the ways to do each task. So it's 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. So it's 2 to power 6. 2 is number of ways to do each task. 6 is number of tasks. Okay. Another example. We know that, okay, license plate for the cars, it's have 2 parts. First part, it's have letters. Second part, it have numbers, okay. So in this question, how many different license plates can be made if each plate contains a sequence of 3 uppercase English letters? So we have here 3 English letters. Okay, if you keep opening your mic, I can make it like this. I will make it that you cannot open the mic. So if you cannot open the mic, then you cannot ask. So try to keep your mic off, or you will make it difficult for your friends to ask. Okay, I will not allow the mic for the attendance. So like this, you cannot ask, what should I do? Because some of you don't care. Some of you actually don't care about you. If you want to ask, then write here your question, and when I finish, I will read your question. Because I turn off now the mics, your mics, you cannot open the mic, should be. Okay, so we have 3 uppercase English letters. So 3 uppercase English letter. And followed by 3 digits, or means 3 number. Okay, so we have 3 digits, 3 numbers. Okay, let's think about answer this one. To get uppercase letter for each digit of the letter, you have 26 letter. So you have 26 ways to select first uppercase letter. Multiply by 26 ways to select the second uppercase letter. Multiply by 26 ways to select the third letter. So we have 26 multiplied by 26 multiplied by 26 to select the uppercase letter. To select the number, we have the choices from 0, 1, 2 until 9. Yes? So how many choice? It's 10. To select the first number. Second number, then multiply by another 10 ways. Third number, it's multiplied by another 10 ways. So how many ways to we have to get different license plates, or how many different? It's 26 multiplied by 26 multiplied by 26. 26 letters, 26 letter multiplied by 26 letter multiplied by 10 numbers, different number for first digit of number multiplied by 10 multiplied by 10. So the number is 17 million 76,000 possible license plates we have. So this is a product rule. Summation rule or sum rule. Okay. Okay, sum rule, it's like this. If we have A1, A2 until AM, different set, such set of establish the task. So we speak about one task, and this task we can do it using A1 ways or A2 ways until AM ways. So this different sets means intersection equal phi. There is no intersection. So the union for them, it's actually the summation. What this means? It's the absolute value, means minus or minus or plus. It's become plus. There is no minus ways actually. Okay. So let's take this example. In a high school, we have 32 students take French class, 45 students take Spanish class. Assume that there is no student take both. So there is no intersection. Intersection equal here 5. There is no intersection between French class students and the Spanish class student. How many students take either French or Spanish? So to do this, it's simply the summation number of students take French plus number of students take Spanish. It's a simple question. So it's 32 plus 45 students. This is the total number of students that we have. It's simple because there is no intersection. If there is intersection, in this case, we have the subtraction rule. So actually, we don't need more examples for the summation rule because it's very direct. You have two different groups. So how many? The summation of these two different groups. But if there is intersection, you need to apply the subtraction rule, or we called it inclusive, exclusive. Okay, it's like this. If you have two sets of way, A1 and A2, then the result of the union, it's like this. You have two sets, and these two sets have what? Have intersection. So if this one A1, this one A2, so the union of A1, A2, it's actually A1, whole A1, plus A2, minus the intersection, minus this one. Okay, so this is a union actually. Let's take this example. In a high school, we have 32 students take French class, 45 students take Spanish, 15 students take both. So there's common shared 15 students between the French class and Spanish class. How many students take either French or Spanish? Either or. So we have 32 take French, 45 take Spanish, minus 15 the shared. So we have 62 students take either French or Spanish, not both, either or. Okay. So let's take some examples or another example for the inclusive exclusive. Focus on this example and see here's a difference. How many bit string. Okay, bit string of length 8. Of length 8. So we have bit string, its length 8. Bit string means each one have 0 or 1, each digit. Until here, it's easy. Until here, what? It's multiplication, yes? Like this example. Same, product rule. But what's the difference here? Here makes the difference. This bit string start with 1 bit or, not and, or with 2 bits 0, 0. So how many bit string of length 8 either start with 1 bit, so either start with 1 or start or end with 0, 0. So cannot start with 1 and end with 0, 0, either or, okay? Either start with 1 or end with 0, 0. So to answer this, we have to understand. So either we have first bit 1 or last bit 0. So to understand this one, look here. This is the possibilities we have that we have. First possibilities that we have, first one is 1. So it's fixed. So we need the way to select the other 1. So this first possibility. Second possibility, we have last 2 digits 0, 0. So we have this way, it's fixed, so we don't need to calculate it. What we need to calculate, how many ways to select the remain, which is 6 digits, because it's 8, this 2, 0, 0 fixed, so this 6 digit, how many ways to select it? When we have first one 1, so we have 7 digits, how many ways to select this 7 digits? And the third one, which is the common here, the shared, when we have first digit 0 and last 2 digits, first digit 1 and last 2 digits 0, 0, we don't need this one. So how many ways to select this one? How many ways to select this one? Minus how many ways if we have first one 1 and last 2 digits 0, 0. This is a question actually. So we have how many ways to get first option? First option, when we have first digit is fixed as 1, we have like this. Let's name this one A ways, this one B ways. So this one A intersect with B. When we have 1 as fixed, 0, 0 as fixed. So this is the intersection. So the idea, we want to get A ways plus B ways minus the intersection. And why we use this? This is the absolute value. If it's minus, it's become positive. If it's positive, it's stay positive. Okay. So to get the first one, we have 2 power 7 ways. Why? Because we have 7 digits. But you said it's 8 digit. Okay. Its length 8, but this one fixed. One is fixed, so different ways. It's depend on the combination for this 7 digits. So we have 2 power 7 ways to select different bit strings. If we have first one fixed as 1. So it's 128 ways to get A. Get A because we fixed first bit as 1. P, we have 2 to power 6. Why 2 to power 6? Because last 2 digits is fixed. How many digits we have? We still have combination. 6 digits only. Each digit could be 0 or 1. So we have 2 possibilities for each digit. So it's 2 to power 6. Actually, to calculate A, we use product rule. It's 2 multiplied by 2 multiplied by 2, 7 times. So you can consider this one, it's a product a problem. This one, it's a product problem. Okay. And this one, it's a product problem. Then you can apply the subtraction rule or inclusive, exclusive rule. So it's 2 to power 6 to select B when we have last 2 digits fixed. And to select the intersection when we have first one fixed and last 2 digits fixed. First one fixed as 1, last 2 digits fixed as 0, 0. We have here 5 digits that need to get the combination. So it's 2 to power 5, which is 32. So the rule is A union B, which is what we need. It's A plus B ways minus the intersect, which is A intersect B. This one we already calculate it as 2 power 7 plus this one 2 power 6 minus this one 2 power 5. So we have 2 power 8, which is actually it's not 160, I think. 128, 100, so 160, yes. Okay, so this number of ways to do the task. Okay, we finished the basic. Now we will start with the Pigeonhole Principle. Before start with Pigeonhole Principle, if you have any question here, you can write your question. I will open the mic for you if you have a question, but next time, if anyone open his mic, I will not open the mics for you again, okay? So I allowed the mics for you. If you have a question, you can ask using the mic. Or if you don't have mic or you cannot ask by mic, you can write your question here. Okay, let's continue. So, you know the pigeon or dove. Okay, so pigeon or dove. Okay, the pigeonhole principle. It's very simple principle, but it's used in many problems around us. So it's easily said, if you have, usually, so let me just show you something here. So this is a vegan holes, okay? This idea. There is many types of vegan holes around the world. It's a place that the vegan stay and live, okay? So what's this rule says? I like this one. Okay. Um, the rule says like this. If we have number of vegan holes more than the number of vegans, this means we have at least one vegan hole that contain at least two vegans. So look to this picture. We have here 12 vegan holes. We have 12 vegan holes. And we have 13 birds. We have 13 vegans or vegans. In this case, at least we have one hole with at least two vegans. We could have here same number of holes, same number of birds. We have some holes that have three, some holes that have two, but at least there is impossible that each vegan hole have one only. There is at least one vegan hole that have at least two vegans. This is the rule. So if we have n vegans more than m, which is number of holes, then at least one vegan hole contain at least two vegans. Okay, it's maybe some will say, oh, it's funny. Everyone know it, but this rules actually it's used in many problems around us. And this principle have theorem. Okay, so this theorem says if k is positive number and k plus one or more objects are put in k boxes, so we have k boxes and we want to put k plus one objects in these boxes, then at least one box contains two or more objects. Okay, I think this this theorem do not need any proof because it's very direct idea. Yes, number of objects more than number of boxes. This mean okay, one box will have at least two or more objects. This common sense that do not need any proof. However, you can read this proof. I will not waste our time for the formal proof here. Okay, let's take some examples for using this Pigeonhole principles. First example, among any group of 367 people, there must be at least 2 with the same birthday. Why? Because there are only 366 possible birthdays. You know, there's 2 types of years, okay, with 365 days or 366 days. Consider it 366, the maximum one. So to show that there's 2 people have the same birthday, we must have 367 people. If we have 367 people, for sure, at least we have 2 with the same birthday, because if the first one born in the 1st of June, of January, second one in the 2nd of January, until we finish with last day of the year, then they are different. The next one must be same with one of the other people. We could have, of course, we could have 100 with the same birthday out of them, but at least there is 2 with the same birthday. Another example, in any group of 27 English words, there must be at least two words begin with the same letter. Why? Because we have 26 letters. So 26 letters, we want to use the words. So we have more than words than number of letters. So this the Pigeon's holes, number of letter. Distribute these words on the letters to know first letter for each word. So, okay, 26 words for 26 beginning letter, but the 27th one must be repeated with other one. So there must be at least 2 that begin with the same letter. Okay, example 3. How many students must be in the class? Look to this example. How many students must be in the class to guarantee that at least 2 students, so it's Pigeonhole principle, at least 2 students receive the same score on the final exam. If the exam is graded on scale from 0 to 100, from 0 to 100. Okay, so the score is actually the Pigeonhole. I want to distribute the students, which is the Pigeon. We can consider the students in these holes. How many holes we have? How many different, okay, how many different scores that we have? From 0 to 100, it's actually 0, 1, 2 to 100. It's actually 101 different mark or scale. Because from 1 to 100, it's 100 way, and we could have one with 0, so it's 101 different scale. I want to distribute this student for the scale. If we have 101 student, we could have each one with different score. Yes, but if we have 102 students, then there's at least 2 students receive the same score. So there are 101 possible different score in the final. So it's actually, we must have 102, which is more than number of scores, number of different score plus 1. So this is the lowest number, okay? So to show that there's 2 students with the same score, we must have at least 102 students. So if we have 102 students, there's at least 2 students with the same score. It's simple principle, okay? But it's have many examples. So this is the generalized Pigeonhole Principle, which is Theorem 2. Theorem 2 says if you put n beacons in k beacons hole, then at least one beacon hole, contains at least n divided by k. And this one, it's not the absolute value, it's the absolute integer. Okay, because we have division here, so the number could have some fraction, but we speak about object. You can't say we have 1.5 beacon in the hole. No, it must be 2, 3, 1, 4, like this. If you say the student, you can say we have 1.5 students. No, it's object. The object could be 1, okay? Cannot be 1.5 object. That's why we don't need a fraction. This means this one, what's the meaning of this one? This one means if we have number x, then we take the smallest integer that greater than x. So first integer greater than x. This is the result. This one, it's greater than or equal x. This one, first integer greater than or equal x. For example, if we have 0.6, then the result for this operation is 1. 3, the result is 3. 4.00001, first integer more than this 4001, which is 5. You cannot say 4. No, it's wrong. It's 5. We need a number greater than it, but first number means the smallest integer greater than this value. Why? Because we cannot say we have for human or for pigeons 0.001. So, and if you said 4 only, if you make it to 4, then you lose here the fraction. So you have to say it's 5. So this is the rule. If you have n beacons, n objects that you want to distribute it in k beacon hole or k boxes, then at least one box or one beacon hole have n divided by k, but we need to take next integer value without a fraction. This is the meaning. We need next integer value without a fraction for this division. If there is no fraction, we take the number directly, like this. Okay, let's take examples to apply this rule or to apply this theorem. Look to this example. If we speak about New York City, okay, in New York City, we have at least 16 people with the same number of hairs. Okay, from where we calculate this one? Number of people when this example created, not now, I don't know now how much. When this example created, number of people in New York City, 8 million. And we speak about number of hairs. Number of hairs is maximum number of hairs for the person. It could be 500,000. Okay, so what's the idea here? How to get how many people we have at least with the same number of hairs? Actually, it's like this. We need to distribute this number for number of hairs. How many different number of hairs we have? Some people have 0 hair. They don't have any hair, have 0. Some people have 1 hair only. Some people have 2 hairs. Some people have 3. Some people have the maximum, which is 500,000. So how many different hairs we have here? 500,001. From where this one come? From the bald person without hair. Okay. So this is the holes, this is the boxes. We want to distribute this people in this holes. First hole, people with 0 hair. Second hole, people with 1 hair. Third hole, with people with 3 hairs, and so on. So actually, this N, this K. So to get how many one, at least we will make N divided by K, but we have to take what? We have to take the absolute integer value. So it's actually 8 million divided by 500,001. Okay, so it's almost 16. It's like this, 15.9999. Next integer value, which is 16 people, will have same number of hair, at least 16 people, at least. This, it's not sure that 16 people have same number of hair, maybe 100, maybe 1,000, maybe, but at least we sure that at least 16 people have the same number of hairs. So this is the idea of apply this rule. We have many examples, and I will send you even more examples, okay, for this pigeonholes. Let's continue. Here another example. Among 100 people, there are at least 100 divided by 12 person who were born in the same month. How many months we have? 12. So if we have 100 people and we want to distribute this 100 people to the different 12 months, we sure that we have this one N, this one K. So we have N divided by K. So we have at least 9 people with the same or born in the same month. Okay. Let's take it like this. If we have, from this example, we can ask another question. If we have 500, okay, if we have 500 people, try to solve it. If we have 500 people, how many one at least born in the or on the same, because when we speak about day, we use on the same day. Okay. Try to solve it. We have 500 people. How many people at least born on the same day? And at least it's very important here, because we cannot know how many born at the same day, but at least born in the same day. How many? Try to solve it. Anyone gets the answer? No, it's not correct. The idea, we need to distribute number of people. So number of people, it's actually the begons here. We need to distribute them on the number of days. So number of people is 500. So this N, we need to distribute it on the number of days in the year, which is 366. So this one K. So the rule, it's like this, N divided by K, which is 500 divided by 366. Actually, if you don't know what's the division, it doesn't matter. It will be 1 divided by or fraction some number, maybe 1/8 something. Doesn't matter. But when you take the absolute integers, this means we have 2 people at least born on the same day. 2 people. Why? Because 500 will be distributed on the 366 days of the year. So to be sure that, or how many person at least born at the same day, 2 people at least born at the same day. Okay, so example 4, what is the minimum number of students required in discrete mathematics class to be sure that at least 6 students will receive the same grade if there are 5 possible grades, A, B, C, D, F. So we have 5 possible grades. And what's the minimum number of students required? Okay, number of students, N. We need to know N. How many students we must have, but here minimum number of students we must have in this course. So we have 6 students receive the same grade. So 6 students is the result. In the same grade it's K. The 5 grades. It's K, number of holes. Actually, it's the idea like this. We have 5 different grades, so you can consider it as 5 different holes. And we need to distribute this students in the hole to be sure that one of them have at least 6 students. So the rule, it's like this: N divided by K, it's equal the number of students with the same grade. So it's equal 6. N, we don't know it, we need it. K, it's number of different possible grade, which is 5. So it's like this: N divided by 5, it's equal 6. So from this, we know that N, it's equal 6 multiplied by 5, which is 30 students. No, it's not correct. This actually the maximum number. Like this, you are sure that each one will have 6, but we need the minimum number. So to think about this idea, we need each hole to have 5 to get the minimum number of students. And then after calculate this, we need 1 to have 6, so a plus 1. So the idea is like this. We have actually 5 holes, and we need each hole to have 5. So 5 multiplied by 5 plus the extra one, which is 1. So we have 26. We must have 26 students, minimum number of students, to show that at least 1 student or 6 students have the same grade. So 26 students is the minimum, because 30, this one, it's actually the maximum number, not the minimum number. So this idea here. Try to solve this at your house, at your home, and next time I will show you the answer. Okay, so we have 2 examples here, 5 and 6. It's speak about playing cards. Okay. So try to solve this one at home. Next lecture, I will show you the answer, inshallah. Okay, so we can take a break before we start for permutation and combination. We can take a break around 15 minutes. So until 11:10, you can return at 11:10. Okay, Assalamu alaikum again. So, how many of you are around now? Raise your hand, please. Okay, let's continue. So, permutation and combination. So until now, we take the basic rule, which is a product rule, summation, and subtraction rule. Then the Pigeonhole Principle. So we speak about distributing objects for something, for weekdays, for months, or distribute objects on the number of days or number of hairs, like the examples. Okay, now we will speak about permutation and combination. Actually, it's um, the difference between permutation and combination. It's about ordering or the arrangement of the objects. So the idea of permutation, when we need to select set of distinct object. Okay, so we need to select set of distinct object in an ordered arrangement. So this is the difference between permutation and combination. Here, permutation, we have order in the arrangement to select the objects. Okay, so if we need to select R elements from N elements in specific order, we name this R permutation. Select R elements from out of N elements in a specific order. This is the most important, the order. So order means the selection is permutation. Okay, so the number of R permutation means select R elements, okay, from N elements. We write it as P out of permutation. N, this the total number. R it's the set of objects that we want to select in order from N object. For example, we have 10 students or 5 students here. We need to select the 3 students from this 5 students to line up for a picture. So we have 5 students and we need to put, okay, we need to put the 3 students from this 5 students to get a picture. So the idea here, how many ways to get first students in the first position, then to get first students for the first position out from 5 students, we have 5 ways. We get first student or second student or third student or fourth students or fifth students. Then after we get the first position in the picture, we need to get the second position. Now we have only 4 students, so we have 4 ways to select the second students. After select the second students, we still have 3 students. So to get for the third position students, we have 3 ways. So 5 ways to select the first student, 4 ways to select the second student, 3 ways to select the third students. So how many ways to select in order the 3 students? It's 5 multiplied by 4 multiplied by 3. So it's 60 way. So to write it formally, it's like this. It's actually permutation because we need to select the 3 students in order. First student, second student, third students out of 5. So N is 5, R is 3, the number of subsets that we need to select from the original set. So the permutation here, it's 5, 3 permutation, which is 5 multiplied by 4 multiplied by 3. We calculate it here. We have rule actually for this. So the rule or theorem to get the permutation, it's depend on the factorial. So first, what's a factorial? You know, n factorial. N factorial, it's actually, of course, you take factorial many times, but again, repeat it. N factorial, it's n multiplied by n minus 1 multiplied by n minus 2 until you reach multiplied by 2 multiplied by 1. So this is n factorial. Okay, now the permutation. Permutation n r, it's the subset that we need to get it in order, the most important order. Okay, order set that we need to get it from n. To calculate permutation, it's actually n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus r plus 1. How many terms we have here? R terms. So if we have a 3, then it's n multiplied by n minus 1 multiplied by n minus 2. If r equal 3. If r equal 4, multiply by n minus 3, and so on. Okay, so the general rule, it's like this. N factorial divided by n minus r factorial. So the permutation of r from n, it's n factorial divided by n minus r. Actually, I don't reply this rule usually. I reply this one. This one very easy. I will show you why it's very easy. Okay, what if n equal r or r equal n? In this case, it's permutation n out of n. We need n set, order set out of n. In this case, the permutation is n factorial. Okay, let's take example for this rules. First example, how many ways are there to select first prize winner, second prize winner, third prize winner? So we have order, first prize, second prize, third prize. So how many one we will select? 3. So R equal 3, but in order. In order means permutation. Okay? So we need to select first prize winner, second prize winner, third prize winner from 100 different people. So n equal 100, r equal 3, because we have 3 winner. We need to select 3 winner, first, second, and third. So it's actually permutation for 3 out of 100. Which rule we will apply? If you apply 100 factorial n factorial divided by n, which is 100, minus r, which is 3, 97 factorial, okay. If you calculate the factorial here and here, it will be very difficult for you. But actually, it's come like this. It's actually 100 multiply n, multiplied by n minus 1, which is multiplied by 9, multiplied by n minus 2, which is n 9, 8, multiplied by n minus 3 factorial, which is 97 factorial, divided by 97 factorial. So 97 factorial was 97 factorial. So it's 100 multiplied by 99 multiplied by 98. So it's like this. How many terms? 3. Start from n, multiply by n minus 1, multiply by n minus 2. So 3 terms. When you calculate the multiplications, this is the result. Okay, let me ask the question like this. How many ways are there to select first and second prize winner out of 10 people or 10 students? So we need what? This is a question. We need first prize winner, second prize winner, out of 10 people. Try to solve it. So we have 10 people. We need to select first winner, second winner. How many? Anyone? Okay. How many ways to select first and second winner out of 10 people? Yes, it's correct. It's 9, not 9, 90. Okay, why 90? Because R it's 2, N is 10. So it's actually permutation for 10 and 2. So we have 10 multiplied by 9. Why? Because we have 2 terms. Okay, so 10 multiplied by 10 minus 1, which is 9. So 10 multiplied by 9, which is equal 90. So we have 90 ways to select first and second prize winner out of 10. Okay, look to this example. A salesman must visit 8 different cities. Don't be very fast. Think here. He must begin his trip from a specific city. It's his home, okay? But he can visit other 7 cities in any order. Then in any order, so it's in a specific order. This is the meaning. Then he must return to his home city. So we cannot consider the home city because he already in the home city and he will return to the home city. But the different combination will be where? In the order of visiting the 7 cities. So we need to select 7 cities from 7 cities in a specific order. So actually, it's permutation for selecting 7 cities out of 7 cities. Selecting 7 cities in order out of 7 cities. When we have n out of n, the permutation is n factorial, which is 7 factorial. So if you have r equal n, then it's n factorial, the answer. So it's 7 factorial, which is 5040, depending on this rule. Actually, this rule comes from this rule. So you have n term here, so it's n factorial. Okay, another example for permutation. In this example for permutation, it says how many permutation means different combination in order, okay? Because permutation means order, okay? Of letters in A, B, C, D, E, F, G contain string A, B, C. Okay, forget now ABC, this one. How many permutation you can get from this letter, actually? You can get A, B, C, D, E, F, G. You can get P, A, C, D, E, F, G, and so on. But we don't need this. We need A, B, C to be like a block, contains this string. So we have these options. It must contain A, B, C, then you can make D, E, F, G, you can make A, B, C, E, D, F, G, you can start with F, for example, F, A, B, C. A, B, C here, it's like one letter because it must appear as A, B, C. So we cannot consider A, B, C different letters. It's one block because the string must contain A, B, C. So this 1, 2, 3, 4, 5. So we have 5 and we need to make a string from this 5 in order. So it's selecting 5 out of 5 in order. So it's permutation for 5 out of 5. So it's equal 5 factorial. Okay. Let me ask same question, but different way. So the answer it's 5 factorial. It's 120. Why it's 5 factorial? because ABC must appear as a block, so we can consider it as a single symbol, only one. What remain? 4. So the total is 5 symbols. So 5 symbols in order permutation from 5 symbols. So it's permutation 5 of 5, which is 5 factorial. Let me ask this question. I want to remove this part. How many permutation of the letters N, A, B, C, D, E, F, G? Who can answer this? Permutation means different order of this letter. How many possibilities you have? How many permutation? Or how many different string you can get from this letter? It's same question. Try to answer it. I don't need the final answer. You can write the rule at least. It's 7. 1, 2, 3, 4, 5, 6, 7. For which one you ask? Here? You mean here why it's not 8? This question? Because it's the 8th city, it's his home. He need to know the order. You are here at this city. How many cities you still have? You still have 7 cities. You need to know in order this 7 city how to visit it, because this your home city, it's fixed. So it's not inside the question actually. So it's 8 city, but first one, it's your home. So it's not inside the 7 cities that you need to have it in order. So the order, it's about in which order you will visit these 7 cities. Because city number 8, it's already your city. Okay, return to this question. How many permutation of the letters in A, B, C, D, E, F, G? Do you know the answer? It's easy. Friends, it's easy. I need permutation from 7 letters. So this means what's the different order for this 7 letters? So it's permutation to select 7 letters in a specific order out of this 7 letter. So it's 7 factorial. This is the answer. When I said the original question, when I said contain a string ABC, then this ABC become like one symbol, become like one letter. So in this case, I will have 5 different symbols because ABC become like one block. So we have 1, 2, 3, 4, 5 out of 5. So it's permutation for 5 out of 5. And it's 5 factorial. This is the original the original question. But without this part, now ABC, without this part, now ABC, it's not one symbol, it's not one block, it's become three different letters. In this case, we have 7 different letters. I need it in order. This is the mean of permutation. What's the order for this 7 letter? So it's 7 letter out of 7 letter in specific order or in different order. So it's 7 factorial. Okay, hopefully you understand it. Why permutation 14 of 7? From where you get this 14? It's 7 letters, and you need to order this 7 letters. So it's a group of 7 letters, and you need to make permutation for 7 letters out of this 7 letters. So it's permutation 7 of 7. So it's 7 factorial. Okay, so now let's speak about combination. Combination, it's set of an order. It's not order, an order selection. So I need to select R combination. Its combination means not order, and an order set out of N. So if you need to select R combination out of N element, we write it as combination R from N. Or you can write it like this. It's combination R from N. What this mean? This mean we need to select subset from the original set, but not in a specific order. The order doesn't matter. You take this one first, you take this one second, you take this one third, doesn't matter. The order doesn't matter here in the combination. For example, how many different ways to select a committee of 3 members? Here, order doesn't matter. We need 3 members out of 10. 3 people out of 10. So, because there is no order, we need to select a committee, okay, of 3 elements or 3 members from 10. So it's combination, not permutation. Why? Because we don't need order. If we said the 3 members, one as a leader and one as first deputy and one as a second deputy, in this case we have order. But generally 3 members in a committee, it's not ordered. So if it's not ordered, so it's combination 3 out of 10. How to solve the combination? This is the general rule. The general rule, if we need to select R out of N as a combination in order rule, so the combination actually, it's n factorial divided by R factorial multiplied by N minus R. Simply, this is the most simple rule. It's actually permutation divided by R factorial. So first R term divided by r factorial. First, r term divided by r factorial. So now let's apply the rule for the first example. How many different ways to select a committee of 3 members? Of course, it's an or unordered from 10 students. So it's combination for 3 out of 10. So it's like this. Let me write it here. So it's combination for 10 and 3. So it's equal. Now get the 3 terms. 10 multiplied by 9 multiplied by 8 divided by r factorial. R, which is this one, yes? So divided by 3 factorial. So it's equal 10 multiplied by 9 multiplied by 8. It's like a permutation, this one. First 3 terms divided by 3 factorial, which is 6. 3 multiplied by 2 multiplied by 1. This is the 3 factorial. So it's 6. So the answer is 120 different ways to select a committee of 3 members from 10 students, because the order, it's not important here. But if the order, it's important, it's permutation. If the order not important, it's combination. Okay, so that's all for today. If you have any question before we finish, I will try to send you exercises, select some exercises from the book, because I did not yet select the exercises. So I will send on Telegram groups exercises that you can do in the book, inshallah. If you have any question, you can ask. Okay, so if there is no questions, then thank you for attend this lecture, and see you inshallah next week. Goodbye. See you. Assalamu alaikum.